Hello and welcome to Rahman Digital Production. That is a new venture by one of the renowned and experienced educationists in the town. We are dealing with the measurement of physical quantities. Yesterday we learned the basic concept of physical quantities and related things to the basics of physics. Today we want to continue that topic, and that topic is continuing with the prefixes of SI unit. Ladies and gentlemen, yesterday I told you that SI unit is the system international unit for measurement. Also, we talked about the 7 basic units of SI unit. Today we will discuss after this topic the first of those 7 base unit, and that is length. But before that, if you haven't subscribed my channel, please subscribe it and press the bell icon so you will be informed immediately when I upload a new video, and that will be a support for me. Okay, let us jump into the prefixes of SI unit. Sometime in science we are writing a very big number, large number, and sometimes we are writing a very small number. So big numbers or small numbers can be written in the physics in 2 ways. One is called the scientific notation, and the second one is called with the usage of prefixes. So ladies and gentlemen, we are talking today about the prefixes of the SI unit. Now in book it is given that there is a table in which it is written 10 raised to the power 6, which is a short form of mega, and that is denoted by the symbol M, capital letter M. So if we want to write 10 raised to the power 6 in common way, then we have to put 6 zeros with 1, which is quite a large number. But if we want to write it in prefix notation, then we, for example, this is watt, which is the unit of power, SI unit. In fact, there is another unit of power that is in British engineering system, and that is the British engineering system is another unit in which we are having this as a horsepower. So that is also the unit. Now very simply we can write 1 megawatt. So see how a big number is represented in a very small way, and that is the specialty of the science subject. Not only physics, mathematics, chemistry, all are dealing in such type of things. So you have to be clear on these things. Ladies and gentlemen, the second one is written is 10 raised to the power 3, which is very technically we are calling it kilo. An uppercase letter K is used for kilo. 10 raised to the power minus 1, and that is deci. We will call it deci, and it is denoted by a small d. Similarly, we are having centi, 10 raised to the power minus 2, and that is centi, and it is denoted by centi small c. Ladies and gentlemen, you are familiar with the fact that we are using centimeter very commonly in the length. So next is 10 raised to the power minus 3. 10 raised to the power minus 3, and this is milli. Just like we are saying millimeter, and it is denoted by small m, not capital M, because that is reserved for m. Similarly, we are having 10 raised to the power minus 6, and that is known as micro. That is known as micrometer, and there is a symbol used which is called mu. It is just like the m, so it is called mu. Mu is the symbol used for a. In your book, example is given 1 kilometer is, for example, if we are writing 1 kilometer is 1 into 10 raised to the power 3 meter. Ladies and gentlemen, we are just writing this in the scientific notation. We are writing this in the scientific notation, and that is in the prefix notation. So if in any question it is given 1 kilometer, so kilo means 1.0 into 10 raised to the power 3, or simply you can write 10 raised to the power 3 meter. Similarly, 1 milliampere, 1 milliampere, ampere is the unit of current. So very small amount of current is this. So if we are writing 1 milliampere, so that will be equal to 1 into, now you can see, then at milli we are having 10 raised to the power 3. 10 raised to the power 3. So we can write this as milli and then ampere, because in minus 3, because in this area this is denoted by m, as you can see here that m is a symbol used for milli, which is 10 raised to the power 3 megajoule. 3 megajoule. Ladies and gentlemen, different people are pronouncing this joule as a joule, but the correct word, as I learned from my teachers in the university, that is joule. So whatever you are pronouncing it, megajoule or megajoule, it doesn't matter, but you have to understand the concept of joule. What is? So if it is mega, so instead of this mega you can write 10 raised to the power 6 joule. 10 raised to the power 6 joule you can write. Then you can write 6 microcoulomb. 6 microcoulomb. 6 microcoulomb, and that is U is also there. So micro, again here it is written as. So You can write 6 into 10 raised to the power minus 6 coulomb, which is the unit of charge. So different question at the end of each chapter, you will see that different questions are given with the prefixes. And when you are measuring the things, I told you yesterday that all the scientists in physics are the people who must understand the measurement first. So that is why these are the concept. There are other units as well. For example, there is nanometer, 10 raised to the power minus 12. There is a giga. The hard disk is measured in gigabyte, which is called GB, terabyte. So there are many are there, but these are the things which are using very frequently inside the O-level course. So I am giving you the basic concept of this prefixes in the SI unit. So we are talking about the SI unit. Next topic is measurement of length. Measurement of length. Ladies and gentlemen, I told you in the first lecture that there are 7 base quantities in physics. In fact, there are derived quantity, but those derived quantities are taken from the base quantity, in which yesterday we talked about the length. So first we are talking about the length, how to measure the length, and length measurement in physics practical. When you are becoming a researcher in physics, then you will use these tools along with other tools for the measurement of length. Ladies and gentlemen, length is measured in meter. In fact, there are sub unit of measurement which is millimeter, centimeter, and etc. But the base unit of length is measurement meter. Okay, because in the next chapter we will study what is the distance. What is the distance? So in advance I am giving you the concept of length, because the definition of distance is the overall path covered by a body. The overall length of a body covered by a body is called then distance. We will discuss that in greater detail, but because length word was coming in that, so I described it for you people in advance. Okay, I told you that length can be measured in meter, but how we will measure that? We are using different material, different tools for the measurement. The first one in your book is given as the meter rule. The first one is given as meter rule. Meter rule. You are familiar with the usage of this meter rule. There are meter rules with me of this length. smaller and larger can be found in the market. So for that particular reason, we are mostly using this scale, which is called meter rule. One is half meter rule, one is meter rule. So if there are 100 centimeter, then we are saying that it is meter rule. But if there are 50 centimeter graduation on the scale, so we are calling it half meter rule. So half meter rule is used to measure the length of object which is not more than 1 meter. We cannot find the length of the roads in kilometer with the meter rule. For that particular purpose, we are using other tools. But small values can be measured which are less than 1 meter can be measured with the help of what? With the help of this meter rule. Ladies and gentlemen, let me tell you that there are graduation on it, and you can see that there are written 11, 12, 13, 14 and long way up to 20s. One is in inches, the bottom portion, and the upper portion is in centimeters. So with this ruler, we can measure the length of object which is about 30 centimeter. For example, if we want to find the length of the width of your book, so for that particular purpose we are using this meter rule. Remember one thing, that if this is the meter rule, so they are leaving certain area and they are starting from here, the 0 or 1. We are not considering this area. So it should be kept in mind that if you want to take precise value, then you have to remove this measurement and you have to start it from here. Why it is like so? Because if it is worn out this area by rubbing, so you can see here that it is given as there is certain area which is not considered, because we have to start it from here like this and we will go downward. So ladies and gentlemen, you have to keep in mind to take precise values. We have to. One thing more, that if we are taking the length of this line, so we don't have to see it from this side or from this side. You have to keep your eye in middle so that you see both the side vertically. If you are not doing so you are committing a parallax error. This is also given that what is the parallax error. If you are having a graduated jar in which there is water and you are saying it from the bottom, you won't be able to take the correct value of measurement. Or if you are seeing it from upside, again you won't be able to take a very precise value. So when you are lining your eye contact with the meniscus of that water, then you are well on your way to get the precise and the most correct answer. So you have to avoid the parallax error. Now the question in the CIE, we will do the past paper as well. In those the question are coming that this material can be measured with which instrument. So they will give you thickness of a sheet. You cannot measure thickness of a sheet with this one, with the meter rule. There are other things used, and that is the second one which is given to you, that is vernier caliper. To measure the length of small object, we are using the vernier caliper. Vernier caliper has upper jaws and lower jaws. These are the lower jaws and these are the upper jaws. Then there is main scale. This is called main scale, and if you give a very closer look to it, this is vernier scale, which is in elliptical form. So there is graduation which is given in elliptical, and this is called vernier scale reading. Now to measurement, first we have to press and close the jaws of vernier caliper and then see that whether the zero of vernier scale is exactly in coincidence with the zero of main scale. So if it is, when you close the jaws and you see that the zero of vernier scale is equal to in line with the zero of the main scale, then it means that this instrument is not having any zero error. First you have to find the zero error. There are two types of error. One is called positive zero error and one is called the negative zero error. Positive zero error should be subtracted from the final value, while negative zero error should be added with the final value. What are these? It is given in your book as well. But if the zero of vernier scale is to the left of zero of main scale, then it is called what? It is called negative zero error. And you have to add this value with the final one because it is on the left side and you took this much error, so this should be added because there is error in the instrument. If the zero of the vernier scale is to the right of the zero of main scale, then it means that this instrument is also having an error, and that is called positive zero error. And then you have to subtract this value from the final value of the measurement. If the zero, I already told you, of vernier scale is in coincidence with the zero of the main scale, then this instrument doesn't have any zero error. Neither you have to add nor you have to subtract any value from the final. Okay, in your book they given you the detailed concept of this. Let me explain how to take the values. Ladies and gentlemen, first you have to take the main scale reading. First you have to take the main scale reading. And the main scale reading is taken as the main. So if you want to take the main scale reading, then if there is written 1, there will be 1, 2, 3, 4 and then 5 again. 1, 2, 3, 4 and 5 again. This will be 1, this will be 2 and this is 1.5. If the circular scale 0 is in the middle of this, because this is 0, for example, if I am increasing it, so it will be 1, 2 and then 3, 4, 5. This is the 1.5. This is 1, so this is 1.1, this is 1.2, this is 1.3 and this is 1.4 and similarly we are having 1.5. So ladies and gentlemen, if we are considering this and this is the 0 is here in the middle of 1.1 and 1.2, then how you will find this? We will take the main scale reading is 1.1. We will take the main scale reading is 1.1 centimeter or millimeter. So when we are taking this, what about this area? We are going to find this through this instrument which is called what? Which is called vernier caliper. So then we have to see vernier scale reading. Vernier scale reading. How you will take this vernier scale reading? If there is 1, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9 and 2. This is 2 and this is 1. Now I am taking only the vernier scale, this portion, not the whole circular. So there will be 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. If you give a closer look, then these two lines are exactly in the same, because this is not in, this is not in, this is not in, and this is also not, this is also a bit. But if you can see that these are inconcide, if you are thinking in my mind, this one is correct, not this one, because this is more straight with each other. So it means that which the 8th digit of vernier scale is exactly in coincidence with the one of the graduated mark on the main scale. So that is your vernier scale reading. For example, here. Okay, now you have to find the vernier scale reading and you have to multiply it with the least count. Multiply it with the least count. In your book, it is given that vernier caliper is having plus minus 0.1 millimeter, plus minus 0.1 millimeter of least count. Ladies and gentlemen, what is least count? Least count is the ability of an instrument that can measure the smallest value. For example, in this scale, what is the least count of this scale? If we are talking in 1 centimeter, it cannot take 0.1. That is not the capability. If somebody is asking you that what is the least count of a clock on the wall, so it is 1 second. The clock cannot count less than 1 second. So that is the least count. What is the least count of vernier caliper? So the least count of vernier caliper is 0.1 millimeter or plus minus 0.01 centimeter. 0.01 centimeter. So this is in centimeter. So we have to write 8 multiplied by 0.01 centimeter, which is equal to 0.08 centimeter. Now, ladies and gentlemen, the final reading will be is equal to main scale reading plus vernier scale reading. Main scale reading was 1.1 plus vernier scale reading is 0.08 centimeter. So it means that we are having the final value is 1.08 centimeter. Ladies and gentlemen, I told you that what is this value in the middle. So it means that it is 1.08 centimeter. 0.8 centimeter. So in this way we can use the vernier caliper, which is another instrument for measuring the length of different objects. There are certainly other instruments, and I want to give you a very in-depth coverage of that instrument in tomorrow's lecture, and that is called screw gauge. So we will talk about the screw gauge, which is more precise than vernier caliper. Vernier caliper is more precise than the meter rule. So screw gauge is more precise than the vernier caliper. That's it for today. Inshallah, tomorrow we will discuss another very important concept. So if you haven't subscribed my channel yet, please subscribe it and support me. Also click the bell icon so that whenever a new video is uploaded, you will be immediately informed. Thank you very much for your time. Allah Hafiz.